Okay, students, in this class I am taking very important theorem in graph theory, handshaking theorem. We have to state and prove handshaking theorem. Okay, so before this discussion, let me take a pen. Okay, a pen I am taking there. The color of the pen, that's what I am interested in. Color of the pen may be of this color I like most. Okay, so what is a handshaking theorem? Now look at that. Now I am taking this graph. So how many vertices are there? V1, V2, V3. So number of edges, how much? Number of edges equals 3. Now what is the degree of this graph? What is the degree? Here the degree is 2. The number of edges going into V1 is called degree. 2 edges are going, therefore the degree is 2. Here also 2 edges are coming inside, the degree is 2. Here also the 2 edges are coming into V3, therefore degree of V3 is 3. Degree of the vertex V1 is 2. Degree of vertex V2 is 2. Degree of V3 is 2 because 2 edges are coming inside. Now edges are 1, 2, 3. Okay, how many edges? 3 edges. Total degree how much? 6. So total degree total degree how much? It is 6. That what we see here, the total degree equals 2 times of the edges. That's what we see here. Okay, so total degrees, that only we are writing as summation of a degree of all the vertices Vi, where I is 1 to k. Suppose k number of vertices are there is equal to, that is total degree. That's what this is equal to 6. Okay, and this is equal to what? 2 times of the edges. 2 times of the edges. 2 times of 3, that is 2 times of the edges. 2 times of the number of edges. That is very, very important here. Number of edges. Number of edges. So shortly saying, summation of d of v equals 2 times of edges in the graph. So this is what we call the handshaking theorem. So handshaking theorem says sum of the degrees of the graph equals 2 times of its edges. So from this single picture we can prove this. So like this, if you take any graph, then this relationship, that is total degree with edges relationships, always true. Okay, so this connection, this relation between the total degree and the edges is called handshaking theorem. Okay, so what is the statement of this handshaking theorem? Is that statement, I can say statement, STATE, statement. That's what this we have to write. Total degrees of a graph equals 2 times of the number of edges. That only we are writing as summation of a degree of all the vertices Vi, where the I varies from 1 to k is equal to 2 times of its edge, 2 times of its edge, or length of the edge. Sometimes some books they are using this symbol. So this is what statement of the handshaking theorem. Okay, now how to prove this? What is the proof? How can we prove this? Okay, how to prove this? And the picture we can give for the proof, for the evidence of the proof, we can give this picture and this writing. But how to prove that? Now look at this picture. Look at this picture here. V1, V2, V3, right? You take this edge or this edge, E1 you suppose, and this edge you say E2, this edge you say E3. Now this edge distribute 1 degree to this vertex and 1 degree to this vertex. Okay, so an edge gives 2 degree 1 degree to this vertex and 1 degree to this vertex. Look at that. Similarly, this edge gives 1 degree to this vertex and 1 degree to this vertex, and E3 gives 1 degree to this V1 vectors and 1 degree to this V3 vectors. So a single edge gives 2 degree to the vertex. So the total number of degrees will be equal to 2 times of its edge. So what is that? Is the proof for our problem. So that is what we have to write here. Okay, now from the picture you can see the picture there. That's what the meaning of this. From this particular picture we see that E1 shares 2 degrees to the graph, one to the vertex V1 So what we understand is that the sum of the degree of vertices of G equals 2 times of its